Hello, everyone. In this video, we will look at the multiple choice questions for chapter 23 of the Java book. First question, the best time complexity for insertion sort is out of n squared. The worst time complexity for insertion sort is out of n squared. Now here is the best time. The best time is out of n. Suppose a list is 2, 9, 5, 4, 8, 1. After first pass of bubble sort, the list becomes. So here comparing 2 with 9, no change. 9 with 5, yes. Swap, now becoming, this is 2, 5, and next 9 with 4, swap, 9 with 8, swap, 9 with 1. So this is D is the correct choice. The best time complexity for bubble sort is out of n. The worst time complexity for bubble sort, it's out of n squared. Next question, the time to merge two sorted lists of size n is out of n time. It's a linear time. The worst time complexity for merge sort is, this is to merge two sorted lists. For merge sort, the worst time is out of n log n, and the average time is also out of n log n. Quick sort. What is correct about a pivot? A pivot divides a list into two sublists of equal size. No. A pivot can be chosen arbitrarily. Yes. A pivot divides a list into two sublists. The elements in the first list are no larger than the pivot, and the elements in the second list are larger than the pivot, right? You should always choose a pivot that divides the list evenly. No, you can't do that. Next question. Suppose you choose the first element as a pivot in the list. So here's 5. Using the partition algorithm in the book, what is the new list after the partition? So here we have this 5, and we're going to look at this 2, 7, 6, and 1. You're going to swap with 9. So this is going to be, and look at this is 2, 1, and now 3 here. So you have this is so this is the this is stay here, and so you swap this this one here, 9 with 1. So this is 9 with 1, 2, 1, and then you are going to swap this 8 with 0. So this is going to be, C is going to be the one. The worst time complexity for quicksort is out of n squared. The average time complexity for quicksort is out of n log n. Using the partition algorithm to partition an array for a quicksort, what is the resulting array after the partition? So here we have this partition. So you are going to look at this 5. So here's 8 is going to be swapped with 2, and so here this one here, and then you have 19 stays. You have 4 is swapped with 10. So it's going to be something like this. 2 swapped with 8. So it's going to be D. D is the one. Next question. Which of the following statements are true? A heap is a complete binary tree, correct? Each node is larger than or equal to any of its children, true. A binary tree is complete if every level of the tree is full, except that the last level may not be full, and all leaves on the last level are placed leftmost. A heap is a full binary tree, no. A heap is represented using an array list if the array list, so this is the array list, is the array list heap. So you can see this, no, this is not, one cannot be there, no. A heap is represented using an array list. Is the array list? No, this is the root and there's 2 children, and yeah, everything's good, fine. Suppose a heap is stored in an array list as follows. The parent of 81, so if you look at this, 155, 92, 23, 33, 81 is going to be, the parent is going to be 92. Next question. To add a new node, you need to start a process by first placing it as the last node in the heap and move it up to maintain the heap property. So that is answer here is B. Suppose a heap is stored in an array list as follows. So this is the one here. After inserting 103, so 103 is going to be the last one here, then compare with the parent. So here is, you have 100 the root, and there's 2 children, 55, 92, and then 23, 30, 81. So you're going to compare this 103 with 92, swap, and then for the swap. So you're going to have this is, so this one here, D. Next question. To remove the root, you need to start a process by placing the last node in the heap to the place of the root and move it down to maintain the heap property. The worst time complexity of heap sort, it's out of n log n time. The average is also out of n log n time. Bucket sort and radix sort. The most efficient algorithm for sorting integers is radix sort. Which algorithm does not compare keys? Radix sort. All right, I'm going to check all the answers now. Oh, good. Everything is correct. All right. Thank you for watching and see you. Goodbye.